Good morning to everyone. Myself, A. Ramanjanelu. In previous class, we discussed regarding the torsion and springs. Okay. In this class, we are going to discuss about the pressure vessels. Okay. In this pressure vessels are mainly classified based on the application, that is thin cylinders, thick cylinders, and spherical shells. Okay. In Unit 4, we are having these three topics. First, we will discuss about thin cylindrical shells. Okay. Coming to syllabus, these are the syllabus we are going to discuss in this unit. That is stresses in thin cylindrical shell due to internal pressure, circumferential and longitudinal stresses, and deformation in the cylinder. Okay. Due to the fluid stored in the cylinder, some amount of pressure will be developed on the walls, internal walls of the cylinder. Due to this pressure, some stresses will be developed. Okay, these stresses is nothing but circumferential and longitudinal stresses, and due to this stress, some strains also developed. So that we are going to discuss about stresses and strains developed in a thin cylindrical shell due to the internal fluid pressure. Okay, next, in the same way, we are going to calculate the stresses in cylindrical shells in the same manner for thick cylinder and spherical shells. Okay. Coming to introduction. Okay. Generally, the application of thin cylindrical shells or pressure vessels in engineering field, we observe in many cases. Okay. The petrol, gas is carried by the lorries, vehicles, or some storage tanks from one place to another place by using pipes, tankers, boilers, compressed air receivers. Okay, all these elements were used to store and transfer the fluids with high pressure from one point to another point. Okay, in that cases, we mainly use these pressure vessels. Okay, generally the walls of such vessels are very thin compared to its diameters. Okay, so that what happened, the amount of stresses will be developed on this pressure vessels. So that we have to calculate the thickness based on the amount of stresses developed in that material. Okay, and which type of the material is suitable and which thickness of the boiler or pressure vessel. Okay, all these we need to calculate based on the stresses developed by the pressure vessel. Okay, in general, the thickness of the wall of the shell is less than the 1/10th of to 1/15th of its diameter, then is known as thin cylinder. If greater the thickness, okay, it is known as thick cylindrical shells. Okay, the same when it is made with a spherical shape, it is known as spherical shells. Okay, next, these vessels when empty are subjected to atmospheric pressure both internally and externally. Okay, without having fluids, in that case only the resultant pressure on the wall of the shell is zero. Okay, it's only subject to atmospheric pressure. Okay, when they are having a storing some amount of fluid, in such case some amount of pressure will be developed on this material. Okay, inside, due to this internal pressure, the cylinder may be split into two ways, or splitted or failure in two ways, that is longitudinally and circumferentially. Okay, when it will be splitted along throughout its length, okay, it may be splitted into two troughs. Okay, in that case, the longitudinal stress will be developed. The circumferential stress will be developed on that material. Okay, in some cases, the cylinder may be splitted into two small cylinders, two halves. Okay, in that case, due to the application of longitudinal stress on this material, it will be developed. Okay, these two ways of splitting will seen in this diagram. In first case, the cylinder may be split into two halves along its length. Okay, due to the application of circumferential stress developed in that material. Okay, in second case, observed here the two cylinders may be formed due to the application of longitudinal stress at the end portion of the cylinder. Okay, observed here the stresses will be formed so that the cylinder may be split into two halves. Next, okay, these are the stresses developed in the cylinder. The walls of the cylinder shell will be subjected to the following two types, that is circumferential stress and longitudinal stress. Observed here in first case the circumferential stress will be developed. In second case the longitudinal stress will be developed. Okay, next, before going to derive the relation to find out the stresses in the cylindrical shells, we need to follow some assumptions. That is, in case of thin cylindrical shells, the stresses are assumed to be uniformly distributed across the wall of the thickness. Okay, during the traveling, the stresses in the inside of the cylindrical walls, it will be vary because it will hit the walls due to the speed breakers or brakes. What happened? It will more effect on some regions. Okay, that means the stresses developed in the cylindrical shells is not uniform. Okay, based on that we cannot find the relations, so that we need to assume the stresses is developed uniformly in the cross section. Next, however, in case of thick shells, the stresses are no longer uniformly distributed across the thickness, and the problem become very complex in that cases. Okay, next, coming to circumference stress, consider a thin cylindrical shell. It is subjected to an internal pressure as shown in figure B. Observed, it is the thin cylindrical shell having some fluid inside the cylinder. Due to this fluid, some amount of pressure developed along the circumference throughout its length. Okay, throughout its length, it having diameter small d inside diameter and outside diameter is capital D. Okay, and it is the P. Due to this internal fluid pressure, it will be splitted into two troughs. Okay, we know that as a result of internal pressure, the cylinder has tendency to split into two troughs observed in figure A. Okay, due to the application of fluid pressure, it is maybe split into two halves. Okay, here the amount of pressure is developed on the inside diameter of a cylinder along throughout its length. Okay, so that we need to calculate the stresses developed in this manner. Okay, for that, first we are going to calculate the force. That force tendency to push the two halves part is given by, that is, F is equals to internal pressure into projected area. Here internal pressure we taken as P and projected area. Okay, the fluid pressure, the fluid hits inside of the wall, that is inside diameter is D and throughout its length, so that the area of the stresses developed on the cylindrical shell, that is D into L. Next, the cross sectional area of material which sustain this force is given by A is equals to 2T into L. Due to the application of this force, it will resist some force, that is along its thickness. Okay, it having thickness, that is in the diameter it is the T. Suppose here one T and here one T, so that it is the 2T, and throughout its length, that is 2T into L. It is the resisting area. Okay, observe, it is the thickness and this one is thickness, so that the total resisting portion in this cylinder is 2T into L. Okay, next it is the like this, it will be split into two halves. Here in this region it offers some resisting force along its length. Okay, like this. Here it is the P, that is applied fluid pressure. Due to this applied fluid pressure, it will offers some resistance. Okay, it is the resistance force. Now we need to calculate whatever the amount of pressure applied on the material, the same amount of reaction forces is developed in the material. Whenever the applied force is maximum or more than the reaction force or resisting force, in that case the cylinder will be failure. That means it will be splitted into two halves, discussed in previous case, that is along the circumferential or along the longitudinal. Okay, now we are going to equating the resisting force is equals to circumferential stress developed in the material, that is sigma c is equals to total pressure developed on the material is equals to total resisting moment, that is it also written as sigma c is nothing but circumferential stress is equals to total pressure by resisting section. Okay, generally we know that the formula for stress is load by resisting force. Here the load is nothing but we are applying force, that is PD into L. Okay, it is the pressure. Pressure equals to force into area. In same way by 2TL. Okay, by simplifying this equation we will get the formula, that is PD by 2T. It is the circumferential stress developed in the material, that is PD by 2T. Note, if eta is the efficiency of the riveted joints of the shell, in some cases the boiler is made up of bolted nuts or rivets. Suppose whenever it is made up of rivets, by attaching the rivets, it will operate some holes on that material. What happened? Due to these holes, some amount of stresses will be developed on the material, that is eta is equals to efficiency of the riveted joints of the shell. So that the stress is equals to circumference stress is equals to PD by 2T into efficiency. When efficiency is 100%, there is no change, that is due to the application of riveted joints are created in these holes. Okay, next longitudinal stress. Coming to longitudinal stress developed in the material, that is consider the same cylindrical shell subjected to the same internal fluid pressure as shown in figure 5. We know that as a result of this pressure, the internal pressure on the cylinder also a tendency to split into two halves or two pieces as shown in figure B. Observe, due to the application of force, it will be split into two halves. Okay, the total amount of fluid is heated on the two ends of the cylinder. Due to this, what happened? It will be split into two halves. Okay, due to this application of pressure, it will give some resistance force along its circumference, this thickness in the circumference. Okay, so we need to equate the applied force developed in the two ends of a cylinder is equals to the resisting force developed by the cylinder. Okay, it is the longitudinal stress. Due to this longitudinal stress, it will give the some resistance to the to this material. Here it will hit the pressure along the circumference. Force acting due to the internal fluid pressure, that is P into pi by 4 d square. Here pi by 4 d square is the area, projected area of the cylindrical along its two ends of a cylindrical shell, so that the cross-sectional area of material which sustain this force is given by area is equals to pi d into t, because it is the circumference of the circle pi d, it having some thickness, so that the area of the cylinder, that is pi dt. Okay, by equating the resisting force to the applied force, by using that relation we can calculate, that is sigma L is nothing but longitudinal stress, that equals to total applied pressure by resisting section, that equals to total pressure already we calculated, that is P into pi by 4d square, by resisting area, that is pi d into t. By simplifying this equation we will get the Pd by 4t. It is the stress developed in the pressure vessel due to the application of longitudinal stress, that is okay. Now whenever we consider the efficiency of the joint, okay, by adding this efficiency in the denominator of the equation, so that the longitudinal stress is equals to Pd by 40 into efficiency. Okay, next, now we need to follow the some points, that is since the hoop stress is twice the longitudinal stress, okay, because observe here sigma L is equals to Pd by 40, okay, it is half of the circumference stress, okay. Here that means the more amount of stress will be developed in the circumferential compared to its longitudinal direction, okay. Next, the cylinder would fail by tearing along a line parallel to the axis, okay. Due to this, the cylinder may be failure rather than on a section perpendicular to the axis, okay. Next, the equation of hoop stress is therefore used to determine the cylinder thickness, okay. It is the main application of hoop stress. Next, allowance is made for by dividing the thickness obtained in hoop stress equation by efficiency, that is steering and shearing efficiency of the joint. In some cases the boiler is made up of riveted joints or welding or any other cases, so that we need to consider that efficiency of a joint, okay. Okay, thanks for watching. In next class we will discuss about the problem regarding the circumferential and longitudinal stresses, okay, and joint efficiency. Okay, thanks for watching.